Hello everyone, welcome back to Explore Electronics. In this video, let's see how to write a program to compute a binomial coefficients of the expression. Let's understand what is a binomial expression. A binomial expression is nothing but an expression which is having two variables in it. So here you can see we have a binomial expression which is a plus b to the power of n. Here we have two different variables a and b. And that's why it is called as binomial expression. Bi means two. So we have two variables and this is the expression that we are going to write. So an expression which is having two variables is called as binomial expression. So if you want to expand this expression, this is how the series of this expression looks like. So it will be given by nc0 into a to the power of n b to the power of 0 plus nc1 into a to the power of n minus 1 b to the power of 1 plus so on till ncn a to the power of 0 and b to the power of n. So if you observe here, the power of a is in decreasing order. So it starts from n and then it is going to decrease like n minus 1, n minus 2 and so on till a to the power of 0. While the power of b is in increasing order. It starts from 0. It is increasing till b to the power of n. Now here you are seeing nc0, nc1 and so on till ncn. So these are our binomial coefficients. So here we have a formula to calculate the binomial coefficients, which is given by c of n comma k is given by n factorial divided by k factorial into n minus k factorial. We also have something called recurrence relation. So a recurrence relation is nothing but an equation that is recursively defining a sequence where the next term is a function of the previous term. So here you can see the nck. This is the term. To find out this term, we need the previous term. Here the n minus 1 c k minus 1 is the previous term. And even here the n minus 1 c is the previous term. So the recurrence relation says that in order to find a term, the function using the previous term will give you the next term. So that is what the recurrence relation means. Now let us understand how to calculate this binomial coefficients in our C programming. So here we have the C program to find out the binomial coefficients and to plot the table for 10 different values. So this is the program. I will explain each and every step in this program so that we will go through the program in each step and each iteration and see the output that we are getting. First, I will show when we run this program what is the output that we will be getting so that it will be easy for you to understand how exactly we arrived at this output. So this is the expected output out of this program. What we are seeing here is a table which is plotted for 10 different values. So here you need to understand what are these 10 different values and what are we exactly plotting here. Let me just explain each of these which is plotted here and then we will go through the program to see how to arrive at this table, how we are doing the calculations to find out the binomial coefficients. For example, if we have something called a plus b whole square, this 2 is the power of this expression. What basically we are doing here is we are trying to find out the coefficient values for the binomial expressions for all the powers starting from 0. That means we are going to find the binomial coefficient values for a plus b 0 and we are going to find for a plus b to the power of 1, a plus b to the power of 2, likewise till a plus b to the power of 10. Just imagine that this is a table like this. Now, for example, consider a plus b whole square. What we will be getting is a plus b into a plus b, right? This is how we can write a plus b whole square. Now, if we are multiplying the two terms with the other two terms, that means we are writing the all possible combinations of this expression. That means we can multiply a with a and a with b. This is two possible combinations. And again we need to multiply b with a and b with b. So what it is going to give us is a into a will give us a square plus a into b is going to give us ab. Now again b into a is going to give us ba and now b into b will give us b square. So now if we further simplify this, we will get a square plus 2ab, because ab and ab is same. We are adding that and we are getting b squared. So what does this mean? We are having 3 different combinations out of this expression, and each these combinations are having the coefficient values. The coefficient of a here is 1. The coefficient of ab is 2. That means this combination AB, we are getting it twice when we evaluate this. How many times we are getting a square? It is 1 time. And how many times we are getting b square is 1 time. So this 1, 2, 1 is nothing but the binomial coefficients of this expression, right? So that means binomial coefficients gives us the count of how many times this combination is occurring when we evaluate this expression. That is what it is going to give us. Now it is easy for us to calculate it for the power of 2. Now imagine if we have something like a plus b to the power of, let's say, 10. So we need to multiply a plus b 10 times and then evaluate it. Isn't it a tedious job to do it? So that's why writing a program which calculates the binomial coefficients for any given expression, we can easily find out the coefficients. That means it is going to give us count of the different combinations that we will get after evaluating this. So the simplest example what we can give is a plus b whole square. So here the 1, 2 and 1 are the binomial coefficient values. This 2 is the power of the binomial expansion. We are plotting x is nothing but the combinations. This is one combination, this is one combination, and this is one combination. So what are this? These are x0, I can say, and this is x of 1 and x of 2. That means 1 combination, 2 combination, 3 combination. That is what here we are having different combinations. For a binomial expression whose power is 2, we are going to get 3 different combinations, and the count is what we call as the binomial coefficient values, right? So in our program we have written x, m and something called binom. So just understand that x is the number of different combinations that we get, and m is the power of the binomial expression. And what are these values that we have plotted here? These are the binomial coefficients. So now let's get into the program and understand each of this, and let's come back in the each iteration and see what is the value that we are getting. Now the program begins with void main, and we are defining our variables. So we just saw in the table that we need m, x and binomial. These are of the type integer. Now we need to print x. Here you are seeing x values. We need to print it from 0 to 10. So we are just iterating with m and then printing it. So we are printing it with 4-digit space. That's why we are getting spaces in between the numbers. Now we need to move to the next line and we are displaying m values. Now just keep in mind that m, we are not going to display all this a column in once. This row we will be iterating and we will be printing 0 to 10. But how can we print this? We need to print each and every row one after the other. So what we are doing is we are giving m is equal to and coming to the next line. In the next iterations we will understand how we are getting 0, 1 and all. Let's begin. So in the next line we are printing m is equal to and coming to the next line. Now we have declared m as 0. So m is 0. Now we are entering the do loop. What we are writing in this do while loop is, see, this is the do while loop. So beginning it will execute without any condition, and then at the end we are checking for the condition. That is what the do while loop does. So we are entering the do loop and we are printing m. Now what is this m that we are printing? It is this. Okay, from here you can see this is what we are printing in the first iteration. In the next iteration we will be printing this. Again in the next iteration this. So these are nothing but the first we will print the m value. Now we are having m as 0 and we need to initiate the value of x as 0. and consider binomial coefficient value is initially as 1, because 1 is the initial value of the binomial coefficient we can have. We are defining it as 1. Now in the while loop, we need to check if x is less than or equal to m. That is because we should not exceed the m range here. Suppose for example, if we are having the expression, suppose we have an expression a plus b whole squared. Now how many different combinations we will get? Is a square plus 2ab plus b square. So how many combinations for power of 2? We are getting 3 combinations, you can see. 1, 2, 3. And that's why to the power of 2 we are having 3 values, that is 3 binomial coefficients. In the same way, for the power of 10, we will be getting 11 different combinations starting from 0 to 10. 0 to 10 means 11 different combinations. So it is always like, I can generally say that a plus b whole to the power of n will give you n plus 1 different combination. So that's why we are checking if x is less than or equal to m. So we need to check if x is less than or equal to m and if it is satisfying. So in the first condition, we all know that m is 0 and x is 0. So what we will be getting? Let us say this is the first iteration. So in the first iteration, what happens? M is 0 and x also we have made it as 0. So x is 0 and we all know that binomial coefficient value initially will be 1. Now our while condition is satisfied because x is equal to m. We have x is less than or equal to m. So it is satisfying, it will go inside. Now again we have if condition. So what we are checking is if x is 0 and m is 0, always the binomial coefficient value will be 1. We have already initialized it as 1. So we just have to print it 1 whenever m is 0 and x is 0. So in the first iteration, m is 0, x is 0. So what will be the binomial coefficient value? It will be 1. So 1 is going to be printed in the output. So this is our first iteration here. M is 0, x is 0 and the value is 1. Now, so it won't enter the else condition. It is because the if condition is satisfied, it is printing. It will directly come out of the if loop and it is incrementing x by 1. Now what will happen to x? X is equal to 1. But m is still 0, only x we are incrementing by 1. Now it is going to again check if x is less than or equal to m. In this condition, it is not going to satisfy. So since x is greater than m, it will not go inside this while loop. Instead, it will come out of this while loop and it is going to next line. This is nothing but next line. And that is why if you observe here, that is why after 1, we are going to next line. We are not having any other values here. Now it will go to the next line and it is incrementing m by 1. So in the second iteration, m is equal to 1 and x starts from 0. Okay, the second iteration, when we enter here, we are again making x as 0. So in the second iteration, the first thing is x is 0 and it will come inside the while loop and it is going to check if m is 0 or x is 0. So in this case, x is 0. So it is going to satisfy this if condition and it will be printing binomial as 1. You can say this as round 1 of second iteration. We are going to get the binomial value as 1. Now, in round 2 of second iteration, what is round 2? We are going to increment x by 1. Now, m is, as usual, we know it is 1 and x we are incremented to 1. Binomial, we got it as 1. Now, let's calculate using this formula. So, binomial is equal to, what was the binomial coefficient value we got previously? It is 1 into, now our m is 1 minus x is also 1 plus 1 divided by x is again 1. So what we are getting is 1. So at the end of our second round, in this second iteration, we are getting two values of binomial coefficient, 1 and 1. So let's see how this is there here. So here you can see, so in the second iteration, we are having 1 and 1. This is how we got 1 and 1. Now let's understand the third iteration too, the same way. So now in the third iteration, now again this x will be incremented by 1. Previously we had x is equal to 1. Now we are incrementing it by 1. So x becomes 2. Now it is going to check if x is less than or m. As we all know, our m is still 1. Now 2 is greater than 1. So it is not going to satisfy this and it will come out of this while loop. Now what it is doing, it is going to next line and m we are incrementing to 1. So m is now 2. So m was 1, we are incrementing by 1. Now m is equal to 2. Now our third iteration starts. So in the third iteration and round 1, we are having m is equal to 2 and x, don't forget that we will be starting off again with 0. And binomial, again we are making it as 1. Now we are checking if x is less than or equal to m. Since x is 0, it is going to satisfy this, and in if condition it is going to satisfy here. So what it is printing? In round 1 we are having binomial as 1. Now after executing this print statement, it is going to increment x by 1. So now in round 2 we are going to have m will be again 2, x is incremented to 1, and binomial again we had it as 1 only here. Now what happens? It is again checking for this condition. It is going to satisfy. Since 1 is less than 2, it is going to enter here and checking if m is 0 or x is 0. This is not going to satisfy because m is 2 and x is 1. Now it will go to the else condition. So in else condition we have this formula, which is nothing but binomial coefficient is given by the binomial coefficient. What we have is 1 into m minus x. M is 2, x is 1. Plus 1 divided by x is 1. So what are we going to get? When we evaluate this, we will get 2 by 1, which is equal to 2. So at the end of round 2, in the third iteration, we are having binom 2. Now again we are going to increment x by 1. So in round 3, m is again 2, x will be incremented by 1, which becomes 2, and binomial is now having 2. Now let's calculate. Again it is going to check this condition. This is going to satisfy because x and m are equal now, and this condition won't satisfy. It will come to else part, and here it again starts the calculation. So what we are going to get here is binomial coefficient, which now is 2, into m minus x, that is 2 minus 2 plus 1 divided by 2. 2 minus 2 is 0 plus 1 is 1 into 2 will be 2 by 2, which gives us 1. So at the end of round 3 of iteration 3, we are having binom is equal to 1 again. So we are having 1, 2 and 1 as the binomial coefficients for the expression a plus b to the power of 2. Why 2 is because m is 2. Now let's see the result what we have got here. So here is our result. We are having, so here we are having to the power of 2, we are having 1, 2 and 1. That is what we have arrived here after calculation. So similarly, for the binomial expression with power 3, 4, 5 and up till 10, these are the binomial coefficient values that we are going to get. So this is how we can plot the table of the binomial coefficients for different values of m and x. So what is m here? M is nothing but the power of this binomial expression. This is our m. And x is nothing but the different combinations that we will get for this particular expression. So here it is a square plus 2ab plus b square. So these are the different combinations. Combination 1, 2, 3. This is x when x is 0, when x is 1 and x is 2. Means we are having 3 different combinations. Here we are plotting from 0 to 10. For every binomial expression which is having the power m, we are going to have m plus 1 different combinations. That is what we saw here. So for power 2, we are going to get 3 combinations, 0, 1, 2. I hope this was clear, and we went through each and every step of this program and understood how the binomial coefficients are calculated and how do we write that in the program. So at the end of the when m exceeds 10, that is when m becomes 11, then it will come out of this do while loop and it is printing the next line. It was going to next line and end. So this is the end of the program. I hope this was clear, and it is the easiest way to understand any program when we run through it. That means we need to run through the program by giving the different values and check the calculations that we will get. Thanks for watching. Keep watching for more C programming videos. Thank you all.